let's see that you can solve that or not, because this is the new technique that, for example, if you have one point is given to you, find the distance, find the distance from the point. The point is given -5, 2, and -3 to the xy plane. Okay, B is YZ plane, C is XZ plane, D is x-axis, E is y-axis, and F is z-axis. Okay, so you have to find the distance of this point from the points, okay, from the xy plane, from the yz plane, xz plane, x-axis, y-axis, and z-axis. Okay, so how you can find, for example, in the last class I told you that what is xy plane means. XY plane means that where you will find the z coordinate is equal to what? 0. So it means only x, y, and 0. So we have a point that is -5, 2, and -3. So this point, if you want to change in xy plane, that point will becomes -5, 2, and 0. Got it? So I convert this point into that one. So how we can find the distance? We know that the distance formula is equal to what? x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay. So substitute the values here. What you will got? What is x2? x2 is -5. What is x1? Minus into -5, that is +5 whole square, plus 2 minus 2 whole square, plus 0 plus 3 whole square, which is equal to square root of 3 square, which is equal to 3. So the distance from this point, to the xy plane is 3. Got it? Similarly, you can easily find the distance of that point to the YZ plane. YZ plane means what? YZ plane means what? That x is 0 and y and z. So this point 5, -5, 2, and -3, you have to convert that into the YZ plane. So you will get 0, 2, and -3. Okay, so substitute in the formula, you will get d what? That is equal to what? 0 plus 5 whole square plus 2 minus 2 whole square plus -3 plus 3 whole square, which is equal to what? Square root of 5 whole square, which is equal to 5. So 5 is the distance of YZ plane. Okay. Similarly, you can find XZ plane. XZ plane means you have y is 0. Okay. So you will got -5, 0, and -3. Okay. So the distance will becomes what? -5 plus 5 whole square plus 0, or you can say 0 plus 2 minus 2 whole square plus -3 plus 3 whole square, which is equal to square root of 2 square is equal to 2. So you will got the distance C, and C is equal to 2. Similarly, you can find x-axis. X-axis means what? Only x-axis means what? That you have to take only the x point, -5, 2, and -3. Okay, so you have to take only the x-axis. That means you have to take only -5 and other terms are 0. Okay, now you have to substitute the point which is equal to what? -5 plus 5 whole square plus 0 minus 2 whole square plus 0 plus 3 whole square, which means square root of 4 plus 9, which is equal to square root of 13. So the distance is square root of 13. Okay, you understand how we can find the distance of one point to the xy plane, yz plane, xz plane, x-axis, y-axis, and z-axis. Can you find that now? Yeah, okay, good. So this is about the distance of any point from the point to the axis. Okay, from the point to the axis, from the point to the plane. So don't confuse when the question is came in the exam. So we know only one point, how we can find the distance. Okay, so you can find the another point from the definitions of the planes. Okay, so now there is another question, and then we'll finish this exercise, which is 11.1, and then we start 11.2, which is uh, you have to find the find the center point and the radius for this sphere. Okay, the sphere is given x square plus y square plus z square plus 2x minus 2y plus 2z plus 3 is equal to 0. Okay, so this I think the same type of examples we discussed in the last class. So what we have to do, we have to just take the x terms separate, y terms separate, and z terms separate, and this number you have to shift on the right hand side, which is -3. Okay, now how I can complete this square? X square plus 2x, I need 1 plus 1. If I add 1 this side, so I should add 1 that side, plus y square minus 2y. For completing square I need 1, so I add here 1. Similarly, for the z, to complete the square I need 1, so I add 1 here. So this is equal to x plus 1 whole square. This is equal to x y minus 1 whole square. And this is equal to z plus 1 whole square. And this is -3 and plus 3, that is equal to 0. Okay. So what is the center point now? The center point will -1, 1, and -1. Okay. This is the center point. And what is the radius here? Radius is 0. Okay, because we have here 0, so radius is 0. Now we go towards the next exercise, which is 11.2, which is about the vectors. Okay, so how we can define a vector? Anybody can tell me how we can define a vector? Anybody can tell me how we can define a vector? A vector is a quantity which has, or you can say which have a length and a direction, represented geometrically by a line with arrowhead. Okay, so what is mean by this one? That if you have any line, this is the line, okay, and the arrow at the head, that is the graphical representation of the vector. Okay, so this is the graphical representation of the vector. Now they also say the tail of the arrow is called the initial point, is called the initial point. What is mean by tail? This point, this point is the initial point. Okay, is called the initial point. Now, and the tip of the arrow is called the terminal point or final point, you can say. Okay, the terminal point. The tip is this point, okay, where you have the arrow. So this is the terminal point of the vectors. And how we can denote a vector? It's very simple because you already studied about this one, that vectors are denoted by small and capitals, or you can say, or capital letters, okay, with an arrow, with an arrow. For example, you have to write here V arrow, A arrow, B arrow, or Z arrow, or X arrow, or you can say capital V, capital A, okay, capital B, or capital Z, capital X, or you can say V dash, U dash, A dash, B dash. So this is the representation, okay? So you can represent either the arrowhead or the line down, you can represent a vector, okay? For example, I say this is a vector V like this one. Okay, so this is the representation of the vector, and how you can denote by using any of this condition. Either you can use this one, either you can use this one, either you can use this one. Okay, so this is the introduction. Now come towards the properties of the vectors. How many properties or uh, types of the vectors you can find? Okay, the first one is that if you have two vectors and you say that two vectors u and v are equal or equivalent, that is only possible and if they have same length, same length and same direction. Okay, for example, I say this is the vector 1, okay, and this is the vector 2, this is u, and this is v. They are same, they are, you can say they are equal vectors when the length of these two vectors are same and the direction is same. Okay, when for example you can say this is the same length, this is the same length of the vectors, but they have two different directions, this is u and this is v, two different directions, but you can't say that they are the equal vectors. For the equal vectors, they must have the same length and the same direction. Okay. Got it? Okay. Now there is another definition. You can say that if the initial and the terminal point, if the initial and the terminal point, if the initial and the terminal point of a vector coincide, then the vector has length 0. Okay, and we call that a zero vector. Okay, and how we can denote this one like this one. Okay, what is mean by this one? That if you have the initial point, for example this one, okay, and the same point is the terminal point, same point is the terminal point. Okay, so for example you say this is a vector, this one is the initial point, this one is the initial point, and this one is the terminal point. If they have the same initial and terminal point, it means the length is 0. Okay, the vector length is 0, and you can say this vector is a 0 vector. Okay, got it? When the length, when the initial and the terminal points are same, you can say they are the 0 vectors. Okay, so how we can add two vectors? If u is a vector and v is another vector, are vectors, then the sum u plus v is the vector from the initial point of u to the terminal point of v as shown in figure. Okay, so I will by graphically how you can add two vectors. For example, you have one vector, this one. Okay, the second vector you can add like this one, because the head of the first vector should touch the tail of the second vector. Okay, so the resultant vector will be like this one, that the tail of the resultant vector will touch the tail of the first vector, and the head of the resultant vector will touch with the head of the second vector. Okay, so this is, for example, you can say u, this is v, and this is, you can say, u plus v. Okay, graphically you can represent. So this is u plus v, which is equal to v plus u. Okay, for example, if I say this is one vector, okay, and you say this is the second vector, and you say this one is the, for example, this one is the uh, third vector. Okay, so this must be the resultant vector. Not this one, this one u plus v will be the resultant vector. So this will one is the first, or you can say the second vector, and this one will be the second vector. Okay, u, v, and u plus v. Okay, so this is the condition from where you can easily find the resultant vectors. Okay, now how we can multiply with a number. Similarly, you can see that if you have any uh, me explain. If V is any vector, V is a non-zero vector. Non-zero. Non-zero means it is not a zero vector. Okay. V is a non-zero vector and K is a non-zero real number. Non-zero means not equal to zero, but it can be positive, but it can be negative. Then the scalar multiple KV. The scalar multiple K is a number scalar and V is a vector is defined to be the vector whose length is K times the length of the V vector and whose direction is the same as that of V if K is greater than 0. Okay, and its opposite to that of V if K is less than 0. Okay, so what is mean by this one? I will explain here. See that, for example, you have any vector is this vector. Okay, this is vector V. You want to multiply with any number. For example, you want to multiply with 2. Okay, so that will be 2V. So this vector will be double. Okay, with the same direction because 2 is positive. 2 is greater than 0, so you have the same direction, but the vector will be double. Okay, for example, if you multiply minus 3V, minus 3V means the length of the vector will be 3 times, okay, but the direction is opposite. 1, 2, and 3, 3 times, that is minus 3V, but the direction will be opposite. Why? Because this minus 3 is less than 0, so it must have the opposite direction. Okay, so KV means the length will be double or triple how much the number you choose, and the direction it's depend on the value of the number. It is positive, you have the same direction. If it is negative, it will have the opposite direction. Okay, understand? Okay, now we have the coordinates, how you can find a vector in a coordinate system. So this is the vector in coordinate systems. Okay, what is mean by this one? That if you have any vector, if a vector V is positioned with its initial point at the origin, then its terminal point will have some coordinates, will have coordinates. What are the coordinates of the form? It will be v1, v2, and v3. Okay, so we can call that in rectangular coordinate system. For example, you can say how you can define this is x, y, and z plane. Okay, this is x, this is y, this is z. Okay, it is say that the initial point is at the origin. So this is the initial point. Okay, this is the initial point, and he say that any point in the xy plane, okay, and you make the vector with this one, okay, so this point is the coordinate of the vector. For example, this is a v vector, so we denote with v1, v2, and v3. What is v1? Basically, v1 is the point at x-axis, v2 means a point at y-axis, and v3 means a point at z-axis. Okay, so v vectors can be represented in the form of coordinate, which is v1, v2, and v3. Okay, got it? So now if the coordinate system of the vector is this one, how you can add two vectors? This is a theorem that if you have u vector, if u vector is equal to u1, u2, and u3, and v vector is equal to v1, v2, and v3 in three spaces, okay, are vectors in three spaces, and k is any number. Then if you want to add two vectors, that means what? You have to add with the component. You have u components plus you have v components. Okay, so how you can add with these components? You have to choose the first component with the first component of v. You have to choose the first component with the second component with the second component of v, and similarly you can choose the third component with the third component of v. Yes, Khalid. Khalid, you want to say something? Okay, this is the addition of two vectors. Similarly, you can find the subtract. Okay, how you can subtract two vectors. So just you have to replace positive with the negative sign. Okay. Similarly, if you have any scalar k, and if you want to multiply with the vector k v, then k, and you have to write here the components of v. So you have to
Doctor,
apply.
doctor.
Yeah.
Sorry, how are you, doctor?
Yes.
Doctor, I have a problem. I can't go.
Which problem? Is everything okay?
No, it is going with my father now.
Oh, okay, okay, go.
Okay, doctor.
Okay, okay.
I am present.
Yeah, it's okay. I will make you.
Okay, thank you, doctor. Sorry.
Welcome. No problem. Okay, so you have to multiply with the scalar with the vectors, okay, for each component of the vector. So that will be kv1, kv2, and kv3. So this is how you can multiply with the scalar with the vector, and how you can add two vectors, okay. So these are the points. Now, if you are, if the 2 points are given, and how you can find the vector from these points. So this is a question that what I said, that if you have 2 points are given, if 2 points are given, then how you can find a vector from that? So vectors with initial point not at the origin, not at the origin. What mean by this one? That if you have the XYZ plane, okay, so this is Y, this is X, and this is Z plane. Okay, if you have 2 points, one point is this one, another point is this one. You have 2 points, and you can draw a straight line. This is means a distance. If you want to find a vector from these 2 points, how you can find a vector? For example, this is point 1, and they have the coordinates like this one, x1, y1, and z1, and this is the point 2, which is equal to x2, y2, and z2. And you can find a vector p1, p2, p1, p2 vector. Okay, so how you can find a p1, p2 vector? P1, P2 vector should be equal to x2 minus x1, y2 minus y1, and z2 minus z1. You can similarly find from this formula. Okay. So if you want to find P2, P1 vector, okay, before we find P1 and P2. So if you want to find P2 and P1, so this is equal to what? X1 minus x2, y1 minus y2, and z1 minus z2. Okay, so you can easily find a vector from these from this definition. Okay, I give you one example, that for example 2 points are given to you. How you can find a vector from these 2 points? For example, a point is given, which is 0, -2, and 5, and B point is given, which is equal to 3, 4, and -1. You have to find AB and BA. Okay, so for AB, you have to you have to use this formula: x2 minus x1, y2 minus y1, z2 minus z1, which is equal to what? X2 is what? 3 minus 0. 4 minus into -2, that will be 4 plus 2, and -1 minus 5, so which is equal to what? 3, 6, and -6. Okay, so now similarly for B2, you have to use this formula: x1 minus x2, y1 minus y2, z1 minus z2. Okay, so this is equal to what? 0 minus 3, okay, -2 minus 4, and then 5 minus plus 1, that is equal to what? -3 minus 6 and plus 6. So this is AB vector, BA vector. Okay, so if any 2 points are given, and if ask you to find a vector, according to that you have to change the formula. Okay, AB formula is different and BA formula is different. Got it? Understand? Is this clear? Okay, so now give you 10 minutes break, and then we start with the norms of vector, how we can find a norm